time shifting operation means if you are giving xt is the input signal, the output signal, let's say xt plus t naught. This is the time shifting operation. Okay, this is the time shifting operation. Now let us consider an example. Let us take this signal. This is xt and this is t minus 1, 0, 1 and 1. Now what is xt plus 1? Yt is xt plus 1. I am taking a value of 1 for this t naught. Can you tell me what is this operation? What happens to this signal? What is the shape of this signal related to this signal?
Sir, it will shift to the left by 1 time unit.
Is it okay? This is the
Like
reference
minus
time. Remember these two reference times, these are the same. Okay, it makes sense only if we keep the same reference time. Now what will happen to the signal? Is it shifting left or right?
Like 1 for minus 2 to 0, it will be 1.
Are you saying this minus 2 to 0? Is it shifting left
Yes, sir.
or right?
So I think
It is shifting left, and it is easy to visualize also. Like if you put t equals to 0 here, then it is x of 1. That means the value of y0 is x1, and value of y of minus 2 is y of minus 2 is minus 1. You can easily visualize that it is shifting left by 1. Now what about xt minus 1? Xt minus 1?
it will shift to the right.
It will shift to the right. So can we say that the first operation is time advance and the second one is time delay? Is it that? Shifting it left means what? We are advancing that signal, isn't it? Is it that? What is the meaning of this? We are shifting it left. For example, in this case, suppose this we can relate it with our previous example, like you are measuring the output across a resistor. There is a switch. So what is the meaning of this? Shifting it left by 1. That means we are closing the switch 1 second before the earlier time. Is it that? T plus 1?
Yes, sir.
We are so closing that switch early. And xt minus 1 means we are delaying that switching operation, isn't it? Is it that?
Yes, sir.
T minus 1. Now can we generalize this? Xt plus t naught, if t naught is greater than 0, if t naught is positive, what will happen? Is it a time delay or time advance?
Advance.
That means you have to visualize also. It is shifting left. T naught greater than 0 and t naught less than 0. It is a time delay. You are shifting the signal right by t naught. In this case, you are shifting the signal t naught, shifting the signal left by t naught, and here it is shifting right by t naught delay. And you have to visualize that. The reason why I am saying that you have to visualize, because normally what I observe in the tutorial classes, in the first tutorial, there will be problems related to this basic signal operations. So what the students usually do is, when I give this example and ask to find, suppose if I am asking to find x of t plus 2, okay, so students many of you first start writing the expression, okay, xt is equal to 1 for t between t less than -1 and 0 otherwise. Okay, then you change the variable, you replace with t plus 1 or t minus 1, then you find the value. It is easy in this case. But when we consider complex signals, for example, if you consider a signal like this, that mathematical expression is difficult, isn't it? It is not that difficult, but it is slightly lengthier than this. You have to write the expression for this part. But if you are given a signal like this, okay, let's say the signal is like this. So don't try to find the expression for this and try to change the variable. Okay, so what you have to do is, this is the operation xt plus t naught. If t naught is greater than 0, you are advancing that signal by t naught. That means you are shifting that signal left by t naught. And if t naught is less than 0, you are delaying the signal by t naught. Okay, don't try to write these expressions and all. If you are given a signal, just shift that signal. Okay, don't try to change the variable and then find the signal. This is for a continuous time signal. Now same for a discrete time signal. If x and, okay, the simplified notation for this is, I'll be using is xt and xt plus t naught. This is the notation I'll be using. That means xt to xt plus t naught. That means we are this is time shifting by t naught. Okay, and sometimes even I use this notation, t to t plus t naught. That means it is a time shifting by t naught. If I am using t to t plus 1, that means the signal we are shifting left by 1. Okay, and the same for discrete time signal. It is x of n to x of n plus n naught. And here there is a difference. What are the possible values of t naught? This is a continuous time signal. The domain is real line. Now what about this t naught? What are the
It will
possible?
be also real.
It is also, you can have any real value for that t naught, isn't it? Now what about this n naught?
Integers, discrete value.
Because here we are talking about discrete time signal. The independent variable is a discrete variable. So here n naught must be an integer, isn't it? Is
Yes,
it?
sir.
So we talk about integer shifts. We can like xn plus 2 means we are shifting the signal left by 2. Okay, and this type of shift is not possible. Non-integer shift is not possible because this must be, the domain must be, the domain of that function is discrete. So here we talk about discrete shift only. Okay, now okay, this time shifting operation, can you tell me, is it an invertible operation? Is it an invertible operation or not?
Yes.
What is the meaning
Yes,
of
sir.
invertible
Yes,
operation?
invertible.
You are starting
Yes,
with a signal, doing some time shifting. Can you get back the original signal? That is that is the invertibility. Can you get back the original signal? Is it invertible operation?
Yes, sir.
Yes, sir.
If we are starting with xt and getting xt, let's say t2. So here what we are doing is we are shifting the signal by t naught. We can write that operation as you are replacing t with t plus t naught, isn't it? That is the operation. Is it? Now what is the inverse of this operation? How to get xt?
T naught.
T
You
equals
have to
to t
replace
minus
t
t naught.
with t minus t naught. Okay. That means let us consider this example. Let's say it is t plus 1. T naught is 1 and this is 1. We are, this t to t plus 1 means this operation is we are shifting it left by 1. Because when t naught is positive, we are shifting the signal left. It is time advancement. Okay, and if we are delaying the inverse of that, if you shift the signal left by 1, the inverse of that operation is shifting it right by 1, isn't it? That is inverse operation. You will get back the original signal. Is it? So this is a time shifting is an invertible operation. Now what about discrete time signal? Shifting of discrete time signal. Let's say this is the signal 0, 1, minus 1. When I have already mentioned that when I write only these three values, it is assumed that all the other values are 0 because the function is defined for all the integer values. These are the only non-zero values or the support of that function. Okay. Now, what is xn plus 2? What is the signal? Is it shifting left or right? Xn plus 2?
Left.
It is shifting left by 2. That means this will go to minus 3, this will go to 2, and this will go to, oh sorry, this will go to minus 2 and minus 1. So the signal will be 0, minus 1, then minus 2, minus 3. This is the shifted signal, xn plus 2. Now what is the inverse operation? If we shift this signal right by 2, you can get back the original signal xn, isn't it? So it is an invertible operation. Is it?
Yes, sir.
You have to shift it right by 2. Okay, so that is the first basic operation. There are few more basic operations that I think we have time for discussing one more operation, that is, let's say, time reflection. Time reflection operation is xt to x of minus t. Now, what is that operation in terms of how can you visualize that? Xt to x of minus t.
Action about y-axis.
Is it reflection about y-axis?
Yes, sir.
For example, this is the signal. Let's say this is minus 1, 2, 1, xt. What is x of minus t?
Mirror image about.
Is it the mirror image? Mirror means it is reflection about the y-axis, isn't it? Is it the reflection about the y-axis? What is this is let's say this is y, basically this is yt is equal to x of minus t. What is y0? What will happen to this value?
Stay the same.
Y0 is x0. That will remain the same. Then what about y1? Is x minus 1. And y minus 1 is x of 1. Is it? So it is, we can say that it is a reflection about the y-axis. Is it? That is the time reflection operation. Is it an invertible operation? So here
Yes,
this operation
Yes,
we can represent it by t2 minus t, isn't it? That is time reflection. It is an invertible operation. If you do the if you do the time reflection one more time, you will get back the original signal, isn't it? You'll get the original signal. So is it an invertible operation?
yes, sir.
It is an invertible operation. This is this is the time reflection operation for continuous time signal. Now, what about a discrete time signal? Is it the same? Same process?
yes, sir.
It is the
Yes.
same process. Is it invertible?
Yes.
It is invertible. Okay. So the third that basic operation is time scaling. The time scaling operation is This is general form yt is equal to x of at, where a is greater than 0. Okay, let's assume that a is equal to a greater than 0, and if a less than 0, there will be an additional time reflection operation. We'll see that we'll discuss that combinations later on. Right now, we let us assume that it is a is greater than 0. Let us consider an example. Let's say this is the signal xt 0, 2, minus 2, and its amplitude is 1. This is the signal xt. Can you tell me what is x2t? If we have a signal yt is equal to x2t, then what is the signal? What is the shape of the signal yt?
One for between -1 to 1 and 0 elsewhere.
Sorry, one for
-1 to 1, 0 elsewhere.
0 elsewhere. It is easy to verify because if you look at this relation, we can see that whatever happening to the signal at t, some instant of time t, that is happening to the signal x at instant 2t. For example, in x, there is a transition from 1 to 0 here at 2. So that will happen to the signal y at which instant? At t equals to 1, isn't it? So there is a transition here, and similarly here, and everything is same, a constant in between that. So this is the signal. Is it? Is it yt? So can we say that we are compressing the signal in the time domain? Is it a time compression? Will it change the shape of the signal? No, it will preserve the shape of the signal, isn't it? That operation, time scaling operation. So here x 2t, that is, it is time compression. We are compressing the signal by a factor of 2. Compression means time compression. We are squeezing it in the time domain. Now what about xt by 2? If we consider xt by 2,
Time expansion.
so yt is equal to xt by 2. You can verify whatever happening to the signal at some instant t, that whatever happening to the signal y at some instant t, that will happen to the signal x at t by 2. So where will this happen in the case of y t by 2? Sorry, x t by 2. This will be moved to where? 4. So is it the signal? Amplitude will remain the same. Is it x of t by 2? Is it that? So we can generalize we can generalize this if x at, if you are this is a time scaling operation, x of at, and if a greater than a greater than 1, we are assuming that a is greater than 0, it is positive constant. If a is greater than 1, what will happen? Is it a time compression or expansion? If a is greater than, sorry, it is compression in time. And if a less than 1, it is expansion in time. Okay, so you have to remember these operations. If a is greater than, it is easy to verify also, like yt is equal to x of at. So if a let's say a is greater than 1, so whatever happening to the signal y at time instant t, that will happen to the signal x at some time instant at. Since a is greater than t, it is a future event with respect to that time instant. So we are effectively compressing that signal. This operation, if a is greater than 1. If a is less than 1, it is expansion in the time. Okay. Now, is it an invertible operation? Here we can, the operation is t2. This is the operation. We are replacing the independent variable t with a into t. Now, this is an invertible operation, isn't it? If you compress the signal, we can expand it in the by the same amount, and we can get back the original signal. So it is an invertible operation. So if this is the operation T to AT, that is the compression operation, what is the inverse of this? Is it this? That is the operation, isn't it? Inverse operation. That means if you are, for example, here in this case, if you are first xt to x2t, that is you are replacing t with 2t, that is the operation compression by a factor of t. Now the inverse operation is from here, how to get back the signal xt? What is the operation t? You have to replace t with, is it t by 2? That is inverse of this operation. This is compression and this is expansion. Okay, so it is an invertible operation. Okay, that is for a continuous time signal. Now let us consider this time scaling operation in the case of a discrete time signal. Yn, this is the general form, x of k times n. Here, what about the value of a here? A is 0, a is greater than 0. It can be any real value greater than 0, isn't it? But what about the value of k? We are talking about discrete time signal. So the domain of that function must be, what is the domain of that function? That is a set of integers. So it makes sense only, this operation makes sense only if when k is an integer. Okay, for the time being, let us assume that k greater than 0 and it is an integer greater than 0. Now, is it the same operation? And one more thing, what will happen if k okay, if it is okay, let us assume that k greater than 0, and let us consider an example. Okay, let's say this is a signal xn. Okay, let us consider this signal 0, 1, 2, 3, minus 1, minus 2, minus 3, and this amplitude, let's say it is 2, and this is 1. This is a signal xn. What is the signal yn? Yn is equal to x2n. What is that signal? Is it a compressed version of the signal? We can sketch it like this. What is the value of y0? Y0 is what? 10 is x0. Oh, sorry, this is 1 and this is 2. These values are 2. So here x0 is 2. This 1 is for this amplitude, okay? So here it is 2. And what about y1? Y1 is 1, isn't it? Is it? Sorry, it is 2. Y1 is 2. What about other values of this? For example, y2. What is value of y2? Y2 is x4. That is 0 because it is non-zero. X is 0, non-zero only up to 3. So all these values are 0. Now what happens in the negative side? So this amplitude is 2. Now what happens in the negative side? In the negative side? What about y minus 1? Y minus 1 is x minus 1, that is 2. And all other values are 0. So this is x2n. Now tell me, is it a compressed version of this signal, xn? It is times. No, it is not compressed version of the signal. Or we can say that the shape of the signal is not preserved here. Is it preserved? That operation preserved the for a discrete time signal, the time scaling operation will not preserve the shape of the signal. Can you tell me what is the reason for that? Why the shape is not preserved?
The half integers we didn't include in domain.
No, the reason is that are we losing some information here?
Yes.
We are losing information. For example, in this case, when we consider x2n, we are losing the information about the odd samples. Is it? Odd samples, we are losing that information.
Yes.
So that's why it is the shape is not preserved. We are losing that information. Okay, and it is true for any value of k greater than 1. Okay, so here this is k. Let us assume that k greater than 1. K is equal to 1. It is the same signal. For k greater than 1, we always lose some information. So is it an invertible operation?
No, sir.
It is not an invertible operation because we are losing some information. And you can easily verify that also. You take, for example, this is not one-to-one mapping, isn't it? For example, if I consider a signal, let's say 0, 2, I'm considering a signal, let's say this is 3, and let's say this is the signal 0, okay, 1, 1, minus 1, something like this. Sorry, this is minus 2. These two signals are different, but if you scale it by 2, time scaling by a factor of 2, will you get the original, the same signal? Isn't it? Because the time scaling, the scaling by a factor of 2 means we are keeping only the even numbered samples and discarding the odd numbered samples. So here, odd numbered samples are different, even numbered samples are same. So we'll get the same signal. So this is not an invertible operation. From this, we cannot get back the original signal. There can be many signals that will give the same yn. Okay. So it is not an invertible operation. So that is a difference between time scaling in the case of continuous time signal and discrete time signal. Will this make any sense?
No, sir.
No, it won't make any sense because this must be an integer. The domain is integer. That domain of that function is set of integers. So we consider k greater than 1. Okay. So there is there is no operation. We can say that this is the operation of the discrete time operation on the discrete time signal that corresponds to compression of that analog signal, isn't it? But there is no operation corresponding to the expansion. Okay, in the case of continuous time signal, we have seen that we can expand the signal, but here there is no such expansion in the case of discrete time signal. Now let me tell you an example. Where do we use this time scaling operation? Can you tell me an example where we use this operation? What we are doing is,
For amplification.
sorry,
For amplification.
amplification. No, here we are compression. Don't get it. Don't be confused with the amplitude modification. We are not here in this time scaling. We are not changing the amplitude of the signal. Sorry, where? Okay, this is one. That is my mistake. The amplitude will remain the same. It is only compression, time compression, either expansion or compression. The amplitude will remain the same. Okay. Suppose I have an audio recording. Let's say it is for 0 to 10 minutes. This is the amplitude of that signal. It is from 0 to 10 minutes. 10 minutes recording. Now, if I want to listen to that audio, at double the speed. What is that operation?
Compression.
Is it compression by a factor of 2?
Yes.
That means we have to squeeze everything to between 0 to 5. That signal will be squeezed, isn't it? It is time compression. So there, the operation is x2t. Okay. So that is an application where we use this operation. Okay, these operations. So these are the three basic operations on the signals. And if you look at all these operations, you can see that they are transformation of the independent variable. In the case of continuous time variable, we are transforming the independent variable t, and in the case of discrete time signal, it is the independent variable n. There are operations that transforms the independent variable as well. Okay, for example, this amplitude scaling, a of xt, y of yt is equal to a times xt. That is amplification. That is transformation of the independent variable. So these are straightforward. I am not going to explain this. These are straightforward. Another operation is, let's say if we have two signals, x1t plus x2t, sum of two signals, difference between two signals. So those are the operations on those are the transformation of the dependent variable. Sorry, this is the transformation of the dependent variable. Okay. Now this is whatever we have discussed is basic operations. There are three basic operations. Now let's see what happens if there is a combination of these operations. Let us consider an example. Regarding this basic operation, one thing you have to keep in mind is that the amplitude of the signal will remain the same. It won't affect the amplitude. Only either particularly this time scaling operation, it either squeezes the signal or expands. So the amplitude of the signal will remain the same. So now let us consider an example of combination of these operations. Let's say this is a signal xt. This is a signal xt. Now let us consider this operation. Yt is equal to x2t plus 3. Okay, let us consider this operation. Yt is x2t plus 3. How many operations are there? It is a combination of how many operations? There are two operations. One is time scaling and the other one is shifting. Now when we say it is a combination of two operations, in which order we should do that operations? First scaling or shifting?
Scaling.
First scaling. Scaling. Okay, here it is a scaling by a factor of 2 and shifting by a factor of 3. Is it? So let us check both the methods, like first scaling and then shifting, and the other case first shifting and then scaling. So if we first scale the signal by 2, then what is the signal? Is this the signal? 0, 1, minus 1, 1. This is the signal, isn't it? Is it? I am first scaling the signal.
Yes.
Now, if we shift it, then what is the signal? Is it shift left or right?
Left.
So where will be that? This will be minus 2. Is it this?
No, sir.
Yes.
Minus 0.52.
Sorry?
Minus
Minus?
0.52 minus 2.
So is it correct? This one? Shift left by 3? Is this a signal? By t?
No, sir.
Yes or no?
No, sir.
No. Then okay. Let us consider the other shift. First, we are shifting by 3. Then what will happen? First, if we are shifting by 3, is it this? -1. Shift this by 3. So this will be shifted left by 3. So -1 to -4. Then you do the compression. This is the operation, isn't it? Minus, what is that? Yeah, it is -5. -1/2 and -5/2. Which one is correct? Left or right? This one or this one? This or this one?
Left.
Left is correct.
No,
Or
sir. Right.
right is correct. So the correct one is this. This is wrong. Can you tell me what is the reason for that?
Sir, because we have to shift by 3/2 in the left one.
Shift 3/2. We are starting with the signal xt. Suppose let us consider these operations like first scaling and then shifting. Then we are shifting by x to t. Sorry, we are scaling that signal by a factor of 2. What is that operation? We are replacing t with 2t. That is the operation, isn't it? That is scaling by a factor of 2. Now, what is the next operation? From x to t, we have to get x to t plus 3. Is it? What is that operation? You have to replace t with what?
T plus 1.5.
You have to replace t with t plus 3/2, isn't it? You have to replace shift t plus t with t plus 3/2. That means this shift is not 3, it is 3/2. And if you do that shift, you will get the same answer. This answer, isn't it? -1/2 -5/2. And if we start with the time shifting operation, we are starting with xt, then xt plus 3. That is, you are shifting the signal t to t plus 3. That means we are shifting it left by 3. And now from here, to get x to t plus 3, you have to, isn't it? That is compression by a factor of 2. So this is the correct answer. And the point here is you can do these operations in any order. Okay? You can do it in any order, but you have to choose that scaling and shifting factors properly. Then you will get the same answer. If you whatever order you are doing, you will get the same answer. And in some textbooks, I think in Simon Hagen, a precedence rule is there. It is always first you have to shift the signal, then scale. It is okay. Sometimes that is easy, but in general, you can do these operations in any order, but you have to choose those shifting and scaling factors properly. Okay, let us consider one more example. Let's say this is a signal xt. We have to find yt is equal to x of 1 minus t/2. How many operations are there? In this case, there are 3 operations. There is a time shifting operation, scaling, and reflection. Okay, so in which order we have to do? We can do it in any order. If, for example, I am starting with, let's say I am starting with xt, and first I am doing xt plus 1, and then x minus t plus 1, and then x of minus t/2 plus 1. Okay, so I am doing in this sequence. What is the first operation? We are replacing t with t plus 1. That means we are shifting the signal left by 1. And the second operation is time reflection. We are replacing t with minus t, reflect the signal. And the third operation is, what is the third operation? Is it, we are replacing t with t by 2. That means we are expanding the signal by a factor of 2. Now let's see the corresponding signals. If we are shifting the signal left by 1, what we get is, sorry, this is, okay, this is the signal after first step, this signal, xt plus 1. This is 0, 1, minus 1, minus 2. The amplitude will remain the same. This is xt plus 1. Shifting it left by 1. Now, the next operation is time reflection. We have to take, it is reflection about the y-axis. So, after the signal is x minus t plus 1 is this is the signal 0, 1, sorry, minus 1, 1, 2. This is x of minus t plus 1. And finally, we have to do the time scaling. Here in this case, it is an expansion by a factor of 2. So the expanded signal is this is a signal by t. Okay, and you can do it in any order. You will get, if you do the scaling and shifting that shifting properly, you should get the same answer. Now let us consider an example of a discrete time. This is a complex operation in the case of a discrete time signal. Okay, let us consider this signal. Let's say this is a signal xn. So 0, 2, minus 1, minus 2, and this amplitude is 1, this amplitude is 2, and this is 3. This is the signal xn, and we have to find yn is equal to x of, let's say, 2n plus 3. How many operations are there in this case? Hello? There are two operations. One is time scaling and time shifting. Can we do it in any order? No, there is a problem here. If we start with the xn and first doing the n plus 3, and then you can get x2n plus 3, isn't it? So the operation is, here you are shifting the signal, replacing n with n plus 3, and here the operation is scaling, time scaling. So it is, okay, so that is the in this way we can get the signal yn. This is yn. And now if we do the time shifting first, sorry, this is first, in this case, first we are doing the time shifting and then scaling. Now if we do the scaling first, starting with xn, x2n, that is, then what about the next operation? How to get x2n plus 3?
So shift by 3 by
Shift by 3 by 2. But does it make any sense? Shift by 3 by 2? Because this is a discrete time signal. Is it? So shift must be integer shifts.
Yes.
So this operation is not possible. This shifting is not possible. Whatever shift we are using, that should be an integer shift. So here, so we should do it in this order. First shifting and then scaling. Okay. And in some cases, for example, x2n plus 4, In this case, can we do it in any order?
Sir, why can't we shift by fractional values in discrete
No,
time
because
signals?
it is not defined for discrete time signals. Fractional set is not defined for discrete time signals because domain of that function is integers. It is defined only for integer values.
Okay, sir.
And another thing is you can visualize that also. Why this shift is not possible? If you are doing x to n, what is happening to the signal? Are we removing some signal? X2n means we are losing information about the odd numbered samples, isn't it? We are keeping only the even numbered samples. Is it that?
Yes, sir.
Yes, sir.
So here first we are in this case first we are shifting and then removing some samples. In this case, first we are removing some samples and then shifting, isn't it? They will not be they will not be equal, and sometimes they are the same. For that is the example here, x2n plus 4. Can we do it in any order in this case?
Yes, sir.
So can we generalize this? When is it possible? When the shifting factor that is an integer multiple of the scale factor, we can do it in any order. Is it? Otherwise, first time shifting and then time scaling.